Greetings. The James Webb Telescope is the most massive telescope in human history. It gives us the capability of discovering and answering questions that was never before possible. I will be going over three main points today: construction, deployment, and capabilities of the James Webb Telescope. Starting with construction of the telescope, it has three main parts: mirror, sun shield, and computing section. The 21-foot diameter mirror is made up of 18 smaller hexagonal mirrors, which are used together to make one large hexagonal mirror, which direct light onto a smaller mirror, and that directs light into the camera, which creates an image. The sun shield, which is as large as a tennis court, is made up of 5 layers, which block all light going to the camera and keeps it extremely cold for the best image quality. The sun shield also has little holes in it, that way on its way to space, any trapped air can escape. The entire telescope is 28 feet tall, and all of the computing works off of solar power charged batteries. It had to be made in a clean room, that way any dust, debris, or anything else wouldn't interfere with telescope components, and everything had to be tested rigorously before it ever left the ground. Moving on to the deployment, the telescope was designed to be folded up into the nose cone of a rocket, that way it could unfold once in space and on its way to its destination, orbiting 1,000,000 miles away from Earth. That being said, each one of the 344 single failure points had to work properly the first time because it would be too far away for astronauts to repair it. The original deployment was actually set for 2007 and 14 times cheaper than it eventually became, and the whole project was almost scrapped several times, but it and the large organization building it persevered until it was finally launched and deployed successfully. Moving on to its capabilities, it has visible and infrared light sensors. The infrared light its wavelengths are too long for us to see and is generated by heat, and that is why the camera must be very cold so it doesn't see its own heat. The reason for this infrared sensor is so that it's able to see light that is redshifted due to the expansion of the universe, and redshifting is when light goes from a shorter, bluer wavelength to a longer red wavelength. This also gives us the capability of seeing back in time due to being able to see light that is further away, up to 200 million years after the Big Bang. If you want to see any images taken by the James Webb Telescope, you can visit webbtelescope.org, and that'll give you any image that it's taken so far. With this telescope, we will be able to test our physics against the reality of the universe and maybe even find new forms of life or new planets that we will eventually call home. Let me end with a story. When I was in basic training, I had to wear night vision for the first time, and they told us to look up at the sky. The North Carolina sky quickly transformed from a meager smudge of stars to a vibrant display of the Milky Way galaxy. But when I took them off, it was gone. How do I see that again? And how do you see something just like I did that night? By looking at images from the James Webb Telescope. And remember, there is no bugs.